Okay, there's a lot of craziness going on around blood type. There always, has been. People think that they should eat based on their blood type, that they should marry someone or not marry someone based on their blood type. Um, Really pretty crazy. So let's talk about the science of blood types. And I just have a little bit of history here. The ABO blood types were actually discovered in 1900 by Dr. Karl Landsteiner. He was actually awarded the Nobel Prize for this work in 1930. He was asking a pretty fundamental question, which was why some patients died as a result of blood transfusions and other people were saved. I think that's a really good question. It took a while to figure out the blood type story because the ABO blood type is not inherited in Mendelian fashion. So if you know about Mendel and the basic ideas of dominant and recessive traits, that does not apply to the ABO system. It is an example of codominance, and in a little bit we're going to see why. But it is genetic. It's like your eye color and your hair color and other traits. So you do inherit it from your parents. In order to understand blood type, antigens, and antibodies, which are not easy, I'm going to talk about donuts and sprinkles for this analogy. And hopefully it will help and also hopefully not make you too hungry. So here's the idea. These are the options that we have for donuts. Some individuals have donuts that have sprinkles on the top that we're going to call A. Some people, different people, have donuts that have sprinkles that we're going to call B, right? So you can imagine on the surface of the donuts, we're going to have these different types of sprinkles. Now, other people, they're going to be a little bit, they like it all. They're going to have A and B sprinkles. And then finally, the last group of people, your last option for donut coverings, is a plain donut. So you're not going to have any sprinkles. I know, it's sad. But, some people have to suffer more than others. These are obviously the ABO phenotypes. Okay, the phenotype is the trait that you express. So if you have A sprinkles, I think it's pretty obvious you're going to be blood type A. If you have B sprinkles, you're going to be type B. If you are A and B, we're going to call you AB. And here's the one that people get a little bit confused. If you don't have any sprinkles, we call you type O. It does not mean that there are O sprinkles, okay? In biology, we use the O to mean the absence of something. Okay, so what it really looks like, of course, is that on the surface of your blood cell membranes, you're going to have these options. The A sprinkle people, you're going to have these particular structures. So these are antigens, these are proteins that the body can recognize. And if you get antigens into your body that you do not already have, you make antibodies against them. Okay, that's the idea. So here are the A sprinkle people, here are the B sprinkle people. These are people with both A and B, and these are the plain donuts type O. All right, so how all this plays out, we're going to be looking at the different phenotypes for ABO that are possible and what's going to happen when you mix each of these four phenotypes with the other blood types. Okay, so we're going to start with blood type O, and we're going to see what happens. First of all, the genotype, this column, this is what your genes say. So we use two lowercase i's to represent the type O phenotype. We'll come back to this column in a second. If you take an O person and you mix them or transfuse them, you give them O blood, everything's cool, right? No problem, that is their blood type. However, if you give an O person a transfusion of A blood, the A antigens, or those A sprinkles, they're foreign to the O person. So you're going to get anti-A antibodies. That's what this means. The O person will release antibodies against the A sprinkles because they're foreign, and the blood will clump. Similarly, if you give an O person B blood, the B sprinkles or the B antigens are foreign, and the O person will make anti-B antibodies against them. So this column represents the antibodies in the blood of the different phenotypes here. An O person has both because both A and B are foreign to the O person. If you give an O person AB blood, boy, talk about a double whammy, right? So the A is foreign, the B is also foreign, and the blood's going to clump like crazy. Next, We have the A blood type. Now, there are two ways you can be A genetically. You can be A if both of your parents gave you the information to make A sprinkles, that is, you're homozygous for A. You can also be heterozygous for A, where one parent gave you the information to make A sprinkles, and the other parent didn't give you anything. You just get a lowercase I, meaning it's a placeholder. It doesn't encode any information for A or B. You can give an A person O blood, and the reason is you're not giving any foreign antigens. That's the key. So an A person can get O blood because you're not getting anything foreign. So it's all good. The A person can, of course, get A blood because that's their blood type, but B is going to introduce a foreign antigen, right? The B is foreign, so the A person will make anti-B antibodies and the blood will clump. Same problem if you give an A person AB blood. The A is okay, but the B is still there. The B is still foreign, and the blood will clump. Hopefully you're starting to get the idea of how this works now. Here's a B person. A B person can be B. Okay, I gotta say it. To be B or not to be B? That's the question. Sorry, it's bad. You can be homozygous for B if both parents gave you the information to make B antigens. Or you can be heterozygous for B, just like the A person. But for the B person, of course, A is foreign. You can still give a B person type O blood because there's nothing foreign, so it's still good. But A is now foreign, so the A will clump. B is okay, and AB, again, is not okay because of the A. Finally, last, we have AB blood. This is really why you see that ABO blood types are an example of codominance. If you have A from one parent and B from another parent, it's not like one is dominant over the other, right? You express both. That's why we call it codominance. The AB person doesn't have any antibodies for A or B in the blood because they've got it all. You can give an AB person O blood. You can give an AB person A blood. They've already got A. You can give an AB person B blood because they've got B. And of course, you can give an AB person AB blood. It's their blood type. So by going through this chart, I think it's pretty easy to see, okay, it's not easy, but hopefully it's a little bit more clear why certain transfusions are allowable and others are not. And you can also see why the O blood type is the universal donor. The O can donate to everybody, and AB is the universal recipient. They can get blood from everybody. So obviously you can see why the O people are much more desirable and you get a lot more calls from the blood bank